Prompt engineering was 2023. Context engineering was 2025. The frontier now is loop engineering. Because modern AI doesn't answer questions, it runs loops. And most agents fail not in the model but in the loop. It's the discipline of designing the cycle an AI runs in, not just the words you feed it. 7 minutes. What agent loops are, the 3 ways they die, and the 5 techniques that keep them alive. Start with the old way. You write a prompt, the model answers once, and that's it, one shot. If the answer is wrong, there's no second chance. The model never even finds out. But look at how a human works. Write code, run it, read the error, fix it, run it again. Nobody writes perfect code blind. The power is in the Retry. So wrap the model in that same cycle. Think, act, observe. That cycle is an agent. The model picks an action, a tool executes it, and the result flows back in. Around and around until the job is done. No magic, just a while loop with a language model inside. One shot is a snapshot, a loop is a conversation with reality. Every agent loop has the same 4 organs. The model, the brain that decides. Tools, the hand shell, browser, code search, anything with an API. The tools define what the agent can touch, nothing more. Context, the loop's working memory, every action and every result lands here. And the stop condition, the rule that says done, ship it. Sounds trivial, it's the part everyone gets wrong. Miss any one of the 4 and you don't have an agent. You have a chatbot with extra steps. One turn looks like this. The model reads the whole context, picks a tool, the tool runs, and the output is appended. That append is everything. The loop literally feeds on its own output. Get this loop right and everything else is tuning. Why bother? One-word feedback. A model that can see its own error messages can fix them. One shot on a hard coding task, maybe 60%. Same model, 10 turns and a compiler to argue with, over 90. The loop doesn't make the model smarter. It makes failure recoverable, and quality compounds every turn. That's the whole business case for agents in one chart. But loops have their own diseases. Disease 1, context bloat. Every turn appends tokens, logs, diffs, stack traces, they pile up and never leave. Watch any long agent transcript, you can spot the exact moment it happens. By turn 50 the window is a landfill. The goal from turn 1 is buried under garbage. Cost balloons, latency climbs, and attention spreads so thin the model forgets what it's doing. You've seen this, the agent that was brilliant for 20 minutes and then suddenly got dumb. That's bloat. The fix isn't a bigger window, bigger windows just delay the flood. A loop that never forgets drowns. Disease 2, the doom loop. The agent tries a fix, it fails, so it tries the exact same fix again and again. 2 identical attempts should be impossible. Without engineering, they're the default. Same action, same result forever, like a fly out a window. You've watched this happen. Install fails, try install, install fails, try install, $20 later, nothing. The loop isn't stupid, it's blind, it can't see its own history. Without a memory of what already tried, a loop is just expensive deja vu. Disease 3, drift. The agent finishes the task, then keeps going, refactoring things nobody asked for, polishing, wandering. A loop without a stop condition isn't an agent, it's a leak with a GPU bill. Drift is why agents feel unpredictable in production. So here's the actual engineering, 5 techniques. 1. Compaction. When the context grows too big, summarize the old turns. Keep the goal, the plan, and the recent state, drop the noise. The loop remembers what matters and forgets the rest. Every serious coding agent ships this today. 2. Sub-agents. Don't do everything in one loop. Spawn a child loop with a clean context for each subtask. It burns its own tokens, then returns only its conclusion. 10 pages of searching collapse into 1 line of answer. And because each child is independent, you can run them in parallel. Speed for free. 3. Verification. Never let the loop grade its own homework. Add a judge. The model can't argue with real tests, a compiler, a second model as critic. The loop only exits through the judge. This one is the single highest leverage fix on the list. 4. Memory. Log every attempt. Before acting, check have I tried this before. That single check kills the doom loop. A ledger of failures is worth more than a plan of successes. 5. Budgets. Cap the turns, cap the tokens, cap the time. When the budget runs out, the loop must converge, or stop and ask a human. No zombie loops. Budgets sound boring. They're the difference between a tool and a liability. Every runaway agent horror story you've heard was a missing budget. Put it all together and a loop stops being a demo and starts being a product. Every serious agent today, coding agents, research agents, computer use agents, wins or dies on these 5. Watch it run. The task fix a failing test in a repo the agent has never seen. Turn 1 Explore. A sub-agent maps the codebase and returns one clean summary. Turn 4 First Patch. The tests fail, and the error lands back in context. The memory ledger records attempt 1. It will never be tried again. Turn 7 The context is heavy, so compaction squeezes the history into 6 lines. Turn 9 A new patch. The judge runs the full suite green. Budget check 11 of 30 turns used, ship it. That's a loop that converges. That's the craft. Zoom out. Prompts are about what you say, context is about what the model sees. Loops are about what the system does. And that's where the leverage is now. Model quality is leveling out, loop quality isn't even close. The models are already smart, the wins come from the loop around them. Whoever masters the loop layer owns the next wave of AI products. That's loop engineering, build better loops.